Welcome to Ælementz, your daily dose of quick insights to strengthen your knowledge. Today, we're talking about the theory of relativity, a revolutionary concept in physics that transformed how we understand time, space, and the universe itself. What is the theory of relativity? The theory of relativity is a scientific framework developed by Albert Einstein that explains how time, space, and gravity work. It's divided into two parts: special relativity, 1905, and general relativity, 1915. Special relativity focuses on the relationship between time and space, introducing the idea that time can slow down or speed up depending on how fast you're moving. This is known as time dilation. General relativity expands on this and explains how massive objects like planets and stars bend space and time, creating what we experience as gravity. To put it simply, imagine space and time as a stretchy fabric. When a heavy object like the sun sits on this fabric, it creates a dent, and smaller objects like Earth roll around the dent. That's gravity in action. Real-life examples include GPS systems, which account for time dilation to give accurate locations, and black holes, which are extreme distortions of space and time caused by massive gravitational forces. What is the history of the theory of relativity? Albert Einstein published his theory in two stages. Special relativity came first in 1905, during what's known as his miracle year. This theory challenged the traditional view of time as constant. Instead, Einstein showed that time is relative. It depends on how fast you're moving compared to someone else. For example, a clock on a fast-moving spaceship would tick slower than a clock on Earth. This became famous for the equation E equals mc², showing that energy and mass are interchangeable. In 1915, Einstein introduced general relativity, building on his earlier work. It explained gravity not as a force, as Isaac Newton thought, but as the bending of space and time by massive objects. One of the first real-world tests of general relativity came during a solar eclipse in 1919, when scientists observed starlight bending around the sun, confirming Einstein's predictions. This discovery made Einstein a global scientific icon and changed how we understand the universe. What does E equals mc² mean? E equals mc² is one of the most famous equations in the world. It tells us that energy, E, and mass, m, are interchangeable, connected by the speed of light, c². Essentially, even a small amount of mass contains an enormous amount of energy. For example, the energy released in a nuclear reaction, like in power plants or atomic bombs, comes from converting a tiny fraction of an atom's mass into energy. A practical example of E equals mc² is the sun. The sun produces energy through nuclear fusion, where hydrogen atoms fuse into helium, and a small portion of their mass is converted into the light and heat that powers life on Earth. Without this equation, we wouldn't fully understand why the sun shines. It's also key to technologies like nuclear medicine, which uses radioactive materials to diagnose and treat diseases. How does time dilation work? Time dilation is one of the strangest ideas in physics, but it has real-world implications. It means that time moves slower for someone traveling very fast compared to someone who is stationary. Imagine two twins. One stays on Earth while the other takes a high-speed trip into space. When the traveling twin returns, they'll have aged less than the twin on Earth. This effect has been proven with astronauts who spend months in orbit on the International Space Station. They return to Earth having aged slightly less than people on the ground because they have been moving faster in weaker gravity. Another example is GPS satellites. They orbit Earth at high speeds and experience less gravity, so their clocks tick slightly faster than those on Earth. Engineers must account for this difference, or GPS systems would quickly become inaccurate by miles. Time dilation is not just theoretical, it's something we adjust for in our everyday lives. How does relativity affect everyday life? Relativity might sound like something far removed from daily life, but it's all around us. One of the most obvious examples is GPS technology. GPS satellites are high above Earth and moving quickly. Because of relativity, their onboard clocks tick slightly faster than clocks on Earth. Without corrections for these time differences, your GPS would be off by kilometers within a day. Every time you use maps to navigate, you're benefiting from Einstein's work. Another example is in healthcare. MRI, magnetic resonance imaging, machines use principles from physics, including relativity and quantum mechanics, to create detailed images of the inside of your body. These scans have revolutionized the way we diagnose and treat diseases. Even the smartphones in our pockets rely on technologies made possible by our understanding of relativity, including the precision of clock systems in telecommunications. What are black holes and how are they linked to relativity? Black holes are one of the most dramatic predictions of general relativity. They form when massive stars collapse under their own gravity, creating a point in space where gravity is so strong that not even light can escape. Imagine an object so dense that its gravitational pull bends space and time completely inward. The event horizon is the point of no return. Once something crosses it, it's lost forever. A real-life example of black holes' effects is the recent imaging of one by the Event Horizon Telescope in 2019. This was possible because Einstein's equations predicted how light behaves near a black hole. Black holes also affect time. For example, in the film Interstellar, astronauts near a black hole experience time passing much more slowly than people far away from it. This concept is directly based on relativity. Scientists studying black holes learn more about how gravity and the universe work on the grandest scales. Interesting facts about the theory of relativity. Fact number 1. Time runs faster on mountaintops. Because gravity is weaker at higher altitudes, time moves faster on a mountain than at sea level. Scientists have even measured this difference using precise atomic clocks. If you live in a tall building, you age slightly faster than someone on the ground floor, although the difference is so tiny it's not noticeable. Fact number 2. Einstein almost failed school. Albert Einstein struggled in school, especially with traditional teaching methods, and was once told he'd never amount to anything. Despite this, his groundbreaking theories changed the world of science forever. Fact number 3. The first proof came during an eclipse. In 1919, astronomers confirmed general relativity by observing starlight bending around the sun during a solar eclipse. This made Einstein an international celebrity overnight. The theory of relativity isn't just about abstract equations. It's a window into the nature of our universe. From GPS systems to black holes, its impact is all around us. What do you find most fascinating about relativity? Share your thoughts in the comments. Thanks for being here. If you find this helpful, consider subscribing. More content is on the way, and I hope to see you again.